Hello and welcome to Unplugged, an IoT podcast where we dive into the fascinating world of industrial automation and IoT. I'm your host, Phil Saboa.
G'day, Phil, and hi, everyone. My name is Ed Fuentes. Well, Phil, today we have a very special episode, actually. We love the idea of IT, the convergence and the way the people, the process, and the technology behind it as well. And today we are talking about technology, and in an interesting way. We're actually not just talking about that technology, but the person who actually helped bring that about. So it's going to be very interesting to conversation. We're kicking off with a conversation about the PLCnext technology, just like the one behind my shoulder here, Phil. And that platform, it's really redefining how automation systems are built and deployed.
Yeah. Our guest today, Martin Boers. Martin is a technical specialist at PLCnext Technology with Phoenix Contact. And with its rich ecosystem, helping companies embrace openness, IT, OT convergence, and the new ways of thinking about automation. Martin, it's great to have you here.
Hello, Phil. Hello, Ed. It's a pleasure to be here.
Maybe you can share a bit about your background and how you joined Phoenix Contact. I know I've been following a lot of the content that you've been generating over almost, I guess, 8 or 9 years. I think I've been following. So yeah, it'd be really good to understand how did you get involved with Phoenix Contact?
Yeah, I mean, I suppose I came from a bit of a different background. I'm actually a chemical engineer by qualification, or process engineer. And yeah, I started working for, well, an aluminium company, Camalco, now Rio Tinto, in Australia, in Melbourne, actually, in the, let's say, the early 90s. And that role it was sort of high-level languages. It was C++, it was thermodynamic modeling, hydrodynamic modeling of aluminium reduction cells. So there wasn't much process control involved in that. Is more sort of high-level language. But I was really interested in the automation side of, well, the aluminium reduction process and just process automation in general. And so I got more and more into the automation system side. And when I started working with PLCs, I was saying, why are my hands tied behind my back? Why can't I program these things in C++, like I had been building these models? And, back in those days, I suppose PLCs were a bit different to what they are today. And, you could only program them in ladder logic or maybe instruction list, these sort of, quite different languages to C++. And even back then, sort of the mid-90s, I was saying, why can't PLCs be different? But of course, that was the history of PLCs, wasn't it? They came from the relay logic, the mechanical, I suppose, relay logic. And I suppose that was digitalized into sort of a PLC platform. So they'd sort of been coming from a different direction to the IT systems. And then I came across Phoenix Contact, I suppose, in the sort of early 2000s. And even then, Phoenix Contact had something a little bit different. They already had these inline controllers. They were those green PLCs. And immediately you sort of saw, well, they've got an Ethernet port on them, like actually on the CPU itself, which was pretty unusual for PLCs. Back then, you usually have to buy a separate Ethernet module to plug onto the side. And so those ILCs that Phoenix Contact produced, maybe 20 years ago, they, even back then, they were based on Windows CE. And, I was getting into sort of C# programming, .NET programming back at that stage, because that was when, Microsoft had brought out .NET and, this idea of the common language runtime. And already Phoenix Contact were putting in an embedded common language runtime into these Windows CE PLCs. And they were basing their PLCs already on this sort of Microsoft or IT type technology. And I thought that was fascinating back then. It was what I had been thinking earlier on. Why can't PLCs be more like industrial PCs? And then, maybe 15 years ago, Phoenix Contact started working on this PLCnext technology, which is rather than being based on Microsoft Windows CE. So I think Windows CE might be, gone by now. So even back then, they shifted to Linux. And so now PLCnext control devices, like Ed has behind him there, they're based on a Linux kernel, which is more common for embedded devices these days. And so, so PLCnext Technology is a PLC based on Linux kernel, and it's open. But I guess we'll go into all the features of it. But it really sort of hit my sweet spot where I said, why can't PLCs be more like PCs and have more of those sorts of features, so you could bring skill sets like mine into the sort of PLC world, rather than assuming people were coming from an electrical or relay sort of logic background into that world, which is still possible. But so I suppose that's a bit of my background and how that ties in, I suppose, with Phoenix Contact and the PLCnext technology. But of course, the PLCnext technology is not just the PLC. I'm probably jumping ahead here, am I?
No, that's fine. No, we Phil, I've got more questions to ask, so keep going.
Yeah, so I don't want it to think that PLCnext technology is just that PLC that you can see behind Ed there. It's actually, well, they call it an ecosystem. So there's actually 4 sort of pillars to PLCnext technology. So one is the PLCnext control device, the actual hardware that you see behind you there. The second pillar is the PLCnext engineer. So that's the IDE, the programming software. So you can use that to program the PLC in these IEC 61131 languages. So I guess your viewers would be familiar with IEC 61131, yeah? So ladder logic,
Absolutely.
function block diagram, sequential function chart, structured text, and so on. So PLCnext Engineer allows you to program the PLC in those languages. But of course, there's further possibilities that I think we'll probably talk about. And then there's the PLCnext Store. That's the third pillar. And that is, I suppose you can think of it like an app store for the PLCnext control devices. It's not intended to be a general app store for all PLCs. It's just really for our own devices, or for devices based on PLCnext technology, which, again, we'll probably talk about is not just Phoenix Contact devices. And then the final pillar is the PLCnext community. So, right from the start, we've felt that the community really is a fairly big part of what makes PLCnext technology work for people. So, potted history. That's the background anyway.
So how did it come about, Martin, from, you mentioned ILC, the times at Phoenix? Where did the genesis of we're going to build one now, like you mentioned, in a Linux environment, or making it more approachable to people who like to program? How did that start? What happened?
Yeah, I suppose it was a bit before my time here, so I can't really talk to the thought process of the people who, the decision makers there. But you can see what they're thinking. Like, these old inline controllers that were based on Windows CE, they were developed by a company called KW Software here in Germany, and they were developing that for Phoenix Contact. About 15 years ago, they were bought by Phoenix Contact, so they're now Phoenix Contact Software. So they really were the ones who developed this platform. And I guess back then, they're looking at what way was the market going, or what way were embedded devices, what was the trend, and Linux was obviously the trend. And I suppose some features of Linux, it is fairly modular, it is fairly open. It has things like real-time patch. It's this preempt RT patch, which allows preemptive real-time scheduling of tasks, and that's what gives PLCnext control devices the real-time capability. And so they built on top of that, and of course the power of hardware as well. That was, I suppose, back around the time, of the first sort of Raspberry Pis. Hardware was becoming lower cost, more powerful. Whatever it is, Moore's law was taking off with the power of processors. So it was possible to put more into these devices as well. So back, the old Siemens S5 days, it was just very low level. It was almost like machine code you were writing for this thing, Did it even have an operating system? I don't know. You were just putting in instructions into this CPU, basically. Whereas now with these Linux devices, there's a whole operating system. You can bring in libraries, open source libraries, third-party libraries. You can run non-real-time components on that platform as well. So we have like an OPC UA server on there. We have data logger. You can run a little HMI, web-based HMI. There's a web server on there. So you can put all sorts of things on there alongside the real-time the real-time tasks. And I guess that's what, even 15 years ago, we could see that was the way it was going. So that's how that evolved. Yeah.
And I'm assuming it took some time for the market to come to grips with like you mentioned, the S5s, all these other traditional PLC devices are out there in the PLC market, because, calling it PLCnext, you're going to give it the affinity to the PLC market as well. So they're going to see, this is the evolution. And you mentioned the whole ecosystem around it. So there are some main differentiators you've mentioned already around the conventional automation solutions. What are are there 2 or 3 things that you go, these is the reason why it's different? I mean, other than Linux, was anything else in your experience you say, well, these are when you talk to end user customers or people looking at PLCnext, what are 2 or 3 things you always say, this is why it's different?
Yeah, it's interesting because I think very early on we had at least one person, one customer sort of contact us, because I work in technical support, so I see all the questions coming in from the customers. And one question we had was, what does the next mean? What's next about this? What's just, I know what a PLC is. What's the next part? And I thought, that's a really good question. I don't know if we ever really explained that. I mean, obviously it's a trademark, for Phoenix Contact. So, I suppose it's marketing more than anything else. But yeah, the differentiators. I mean, these days, I suppose other vendors have sort of caught up and sort of have sort of replicated the kind of stuff we're doing. But the openness, I think, is really, and we noticed very early on that people, I guess, with a similar background to mine were coming in saying, oh, finally, they'd been using sort of Raspberry Pis and thinking, can I use a Raspberry Pi for industrial control? Not really. It doesn't really have the vibration, doesn't have the temperature range, it doesn't have the added on industrial I/O. On the right side there, you can see behind Ed, there's this industrial I/O you could add on. So it's Raspberry Pi, not really. But here was a device that seemed to do what people with my background had sort of been waiting for. So we had those people coming in, trying to run C++ code on it, trying to run, and straight away we saw the things people were trying to do with it. I thought it was a real eye-opener. They're trying to run Python applications on it. They're trying to put their own web server or run their own web-based applications on it. Implement communication protocols, these sorts of things. But at the same time, you really have to cater for people who just want to use it as a PLC as well. Just coming from the IEC programming background, they're happy with that. It does what they want, because that's the other thing. You want to give people choice, right? You want them to be able to choose the best solution for their project. So sometimes people say, oh, what's the best IEC language to use? How would you guys answer that? There's a question for you guys. How would you answer? What's the best IEC language to use?
We actually discussed this on a previous episode, actually, and we came to the conclusion that it's, you choose the one that is right for your situation, right?
Exactly.
And we learned that from previous experiences that sometimes you don't always know what that is. But yeah, I can definitely see, you're choosing the right one for that situation. But we're seeing, I guess, a leaning as the market evolves. We have more graduates coming up through the rank. They're more familiar with structured text type languages. So yeah, you have to kind of cater for that in a product marketing point of view. Have to be able to support structured text as a move forward.
I've seen the same thing. Sometimes some projects have a combination of all the languages in the one project, in the one PLC. Someone's done some functional library and some ladder logic inside of it, and structured text and sequential programming. So we see a lot of it happening, and you're right, Phil's to the point is that whatever you're comfortable with. It makes it difficult though, because if you're comfortable with something, it's not not always the one troubleshooting it. There'll be someone else who comes in. You might have done it in structured text, and someone who knows ladder logic is going to look at it and go, what do I do with this? So the ability for having to create that code in different languages that make sense to the user. So there's 2 things. One is who's programming it and who's going to troubleshoot it afterwards, which is
I think moving forward, though, structured text is going to be the way forward, right? We're looking at large language models that can understand more, I guess, text-based functionality. Maybe they can write function block in the future, I'm not sure, but at the moment they're kind of only stuck to the structured text. So yeah, it's going to be an interesting move forward, but I think absolutely having the flexibility to cater for not just the users but also the programmers, it's going to give you the best of both worlds moving forward. So I totally agree, Ed.
And in
Definitely
that space,
do that.
in what you're saying there, Phil, that's the other thing, is that now we've got these programs. In the past, you would have seen this. You put the PLC in a lock cabinet and you lock it over there and no one touches it. When Ethernet came out, it would have been the whole issue about how do we air gap this, protect it from the evils of the internet or whatever it might be. But now, as Phil's mentioned, large language models, the introduction of AI, the ability to use IT software to help manage change control. All of a sudden, the PLC just can't sit in OT. It has to work in an IT environment. So in that space, what are the conversations you're having right now with IT and OT convergence? And how does PLCnext help address this issue or these challenges?
Oh, there's so much to talk about. I want to put a pin in that question, Ed, if you don't mind. And I want to go back to that question about languages, because I want to just say I agree with 100% with what both of you said, that the language you choose is not just who's developing it, and I suppose not just who's maintaining it, but what are the characteristics of the process you're controlling? So if the process has features of a sequential, I don't know, maybe a batch process for a pharmaceutical plant or something, maybe that suits sequential function chart where you have a sequence of operations. If it's, I don't know, a continuous process, maybe it suits some other language. So you have to look at the process that you're controlling, as well as, the skills of the developer and how easy is it going to be to maintain. I know when I first went to Siemens S5, I just wanted to do instruction lists, this basically machine code, because that was what I was most comfortable with. But I very quickly thought, well, hang on, does this suit this application? What about the people coming after me? Are they going to be able to understand this? So you have to have that flexibility, I suppose, you have to choose the right language for the right application. But I suppose tying that back into PLCnext Control now, we've taken that one step further, saying, well, you're not now restricted to the IEC languages. You now can develop function blocks in C#. We have the embedded common language runtime running in the PLC, so you can compile your C# to run on this common language runtime. You can develop function blocks or programs in C++. So if you have those skills, and if the application suits that, maybe there's an open source library, C++ library you want to use that does some fancy, I don't know, matrix manipulation or something. You can incorporate that into your function block. And then we've also extended it to running Simulink, MATLAB Simulink models on the PLC. So you can build a model in Simulink, compile it, run it on the PLC. You can debug it. You can visualize it on the PLC. So we're trying to make it more open and give the developers and the users a bigger choice about what language they use, whether it suits that application or not. So back to your question about the IT and the OT convergence. You're absolutely right. I remember back in the day, we would work in the automation space in the factory, and the IT guys would be like, oh, okay, here's your Ethernet cable. I've given you this set of IP addresses. I've put this massive firewall on the office side of the network. You guys just do whatever you want out there. I don't want to know about it. You do whatever you want. You assign your own IP addresses. You manage your own devices. I've just got this big firewall here, and I don't want to know about it. And there was this big separation between, the OT, the people in the plant. We thought that was great. We could do whatever we like with this network. We could. Obviously, there was no internet access, I guess, back then. You'd have to go into the office for that. And the office guys, the IT network managers just didn't want to know what was going on in the plant. Maybe you'd send a file across to them once a day or something about what was going on in the factory or something. But now, everything is converged, like you say. It's gone are the days where there's an air gap or even a firewall between these things. Like I say, the Phoenix Contact inline controls back then were quite rare to have an actual Ethernet port on the device. Obviously, these days, every PLC has an Ethernet port, a standard on the CPU. So they really need to be treated like a network device that's managed as part of the entire factory network, the office network, like all the printers, like all the PCs and so on. So these devices need to be full participants on a professional, a modern Ethernet network, whether it's a LAN or even a wide area network. And obviously there's challenges with that. I mean, we know from the Stuxnet days, what happens when you put PLCs onto a wide area network, or what can happen. I guess, wasn't it in your own area there, Phil, in the Gold Coast? Wasn't there a famous water treatment plant case? No?
Yes.
Is that right?
Yes, I think
Yeah.
so.
Okay, let's not talk about that. So really, I mean, yeah, it's a real challenge for PLC vendors to manage this sort of thing. So I don't know if you know, in Europe, there's this thing called the now I'm gonna mess the name up. The CRA, Cyber Resilience Act. They've just been working on that in the last few years in Europe. So, and that's coming. Like that's going to require every device. It's not just automation. It's consumer products, everything. Every device that is connected, so has an Ethernet port and has any sort of digital aspect to it, comes under this regulation, and it needs to have certain security features. And it's not just the features of the product itself. The whole manufacturing process, the whole development process has to also be certified. So yeah, I mean, you might get a router come in from some unknown country and it might look fine, but that whole manufacturing process also has to be certified, so it's all secure and yeah, there's no
Wow.
sort of security holes there. So I mean, that's not really a problem for Phoenix Contact, because right back from the start, everything was designed with sort of security in mind. And so yeah, I dare say we're sort of at the forefront of that. We're right on top of the Cyber Resilience Act already, and I think we even had an audit there last week. So yeah, I think some companies might be sort of scrambling a bit to sort of catch up with to implement sort of what this act requires. But yeah, there's no problems for us. I mean, these devices already had a firewall in them right from the start, and that's something that's familiar to any IT network administrator or manager. You can just manage the firewall in the PLC the same way you manage firewall in any other devices. And there's a network load limiter in there. Yeah, there's just trying to think of some of the other security features. But it's yeah, that's what I was going to say. Even the user management, it's not like you have the password sort of written on the housing of the PLC or on a sticky note stuck to the PLC. You can't do that anymore. So, for instance, these PLCs have LDAP or LDAP client capability. So LDAP, I don't even know what that stands for, but that's, for example, Microsoft Active Directory, where IT network managers can manage all the user logins, give permissions to each of the users and so on. So let's say, for example, when somebody leaves the organization, you just suspend that account and it's suspended everywhere. They can't log in anywhere on the network. Well, these PLCs have an LDAP client built in, so you can actually authenticate users against your company's LDAP server. So that means, yeah, when a person leaves, deactivate that account, they can't log into the PLC anymore. And you can give them different permissions in the PLC as well. They might be able to view certain pages on a HMI, or might be able to do certain hack things. So, yeah, it's a long answer to a short question about how we're sort of converging these IT and OT features. Yeah.
Yeah, they're really good points though, because when we talk about IT and OT convergence, we're talking about IT, possibly having more responsibility over OT type operations, and if they can have confidence in the mechanisms of, rolling out firewalls or managing user permissions, using common IT language, they're going to be much more comfortable with the OT solutions coming in and, being added to the network, because they're kind of understanding, okay, does it support LDAP? Does it support certification, certificates on the device, secure connectivity, using protocols that they might have heard of or understand, as well. So, yeah, it's definitely a step forward in the right direction.
Yeah, I mean, it's a learning thing for us as well. Like you say, the certificates is one thing that I didn't really know much about security certificates, and of course we have those on the PLC. The web server has a certificate. I mean, it's just our own sort of what do they call it? The self-signed certificate
Yep.
by default. So it's untrusted. When you open the browser, it says this certificate is untrusted. And we go, oh, what's wrong? What's wrong? So well, you need to generate your own certificate, get assigned by a certified authority, and blah, 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 blah. I mean, all that was a learning process for me as well, you know. So people, yeah, it's people sort of have to learn more. And like you say, some of these protocols, like when we first launched this PLC, people are saying, "Oh, I want to use MQTT," and I'm like, "What's that?" Like, I knew OPC UA, like, well, I knew the old OPC based on was it some Windows technology? Well, it was the old COM technology, wasn't it?
Com,
The old OPC.
DCOM.
And then OPC UA. So I knew all about that. But this MQTT, what was that? Well, it's this web-based, messaging or subscriber technology. So yeah, we learned about that. Now we have libraries, the MQTT libraries right on there. So yeah, it's really interesting that the people coming at these things from all different sides really brings up the knowledge of everybody, I suppose, who are using these devices. So it's really interesting. Yeah.
I guess for the listeners, I guess maybe a bit of my background is that I used to work for Phoenix Contact many moons ago, and one of the first, my kind of getting interested in automation was around, this, crazy kind of IT centric PLCnext technology. It was one of the first kind of passion pieces for me. Driving innovation here, everyone knew Phoenix Contact for terminals and for
Yes.
maybe a couple of the ILCs, and PLCnext came in. I was like, this is something that I can really get my teeth into, really get to understand. I had one of those PLCnext technology trainers, and I got to play with it. I was like in one of the first classes here in Australia. Me and one of my now colleagues, Paul Kadzir, were in the first class of Australians to learn about PLCnext technology as well. So that was really fun, and I was willing to test the boundaries, and a Linux operating system. I'd got my hands on some Raspberry Pis. I installed Node-RED onto the controller, and I was like, well, we can bridge so many gaps here with OPC UA nodes just straight out of Node-RED, straight to the real-time engine on the PLCnext. And, that enabled, us to really tap into the IO count on the board itself, like just address everything really quickly, browse the device, make it's super innovative. It was like really kind of game changing for me. I was like, this is the next bit, because I was really in love with another PLC that Phoenix Context does, which is called PLC Logic. And that was like the smart relay type system, where it just clips onto the top of your relays. And so the PLCnext was like the next step on that, Ethernet enabled. You could install Node-RED onto the device and kind of create your own dashboards in that, or in the HMI software. So it was a really fun time to be able to play around with the controller. I really enjoyed myself at that time.
Yeah. I suppose it's at the end of the day, it's still an embedded device. It's a relatively well, depending on which controller you go for. The one behind there, I suppose, is almost the entry level model.
2150, yeah.
Yeah, we have an 1152 as well, a slightly smaller one, and we're actually launching a 1252 in the next few weeks. I think maybe there's a exhibition in Nuremberg next week. I think it's the biggest automation exhibition in Europe, maybe the world.
SPS, is that the one?
That's it. Yeah, the SPS. Yeah, Smart Production Systems or something, I think they call it now. And yeah, I think we'll be launching, this new PLC next week. So yeah, but at the end of the day, it's a relatively resource limited device. It can't do everything. And we did have some people, I suppose early on and even now, see this and almost be too over ambitious, you know? And I was the same. I was the same at the start. You sort of push the limits and see what can you do with this thing. I mean, the first thing people will notice who come from a Linux background is it doesn't have APT. It doesn't have a package manager built in. So you can't just, well, you can connect it to the internet, you can ping Google, and then you say apt install, and apt isn't install, like doesn't work. So people say, well, where's the package manager? Okay. We don't have things like that. And, you know, so there's the first sort of, let's say, disappointment. So you just need to learn what I suppose the limitations are. And one thing, if people want to implement non-real-time things like Node-RED was a classic. That's, again, I'd never even heard of Node-RED. Maybe you introduced me to it, Phil, I'm not sure. But yeah, it was things like that. Containerization, like Docker containers. I had very little experience of that sort of thing. And then people are trying to install Docker containers on this thing. And now that's just the standard thing that people do. Is some PLCnext Store apps, we have a container-based. We actually now implement a virtual PLC in a container. I mean, there was even talk, I was talking to somebody who said, well, why aren't all our PLCs just virtual? Like, why isn't it just hardware running Docker and all the PLC stuff is just a container, like running on this hardware? That's a really good question. Like, that could be the way it's going, you know? But then the challenge is, how do you get that real-time capability inside a container, which we've actually managed to do with our virtual PLC. But that's the thing. This is, at the end of the day, what differentiates it, I suppose, is that it is for real-time deterministic control. And what do we mean by real-time? Well, maybe you guys have an opinion. What do we mean by real-time?
From my point of view, real-time is as close to, I guess, fact as possible. Right? Like, there's not always a case where you have, you know, nanosecond resolution, and do you need it all the time? That's not
Exactly.
not the case as well. So yeah, it's a very interesting, I guess, perception of what is real time. And it's real time means to me is you know, as close to true as possible for me.
Yeah.
Ed, do you have an opinion on that one?
Oh, look, on the same field, in real time, it means different to different people. Like the weather in real time, it might be to 6 decimal places, but I only need to know what's the most significant decimal places for my knowledge anyway. But because the PLC's capability is to, what is it, a 16-bit, 32-bit what processor, I'm assuming. So you can get quite high level of granularity. But what is real time is, you're right, to what the data requires. And not just that, also like to know what is the error in my real time. What is the difference between, okay, because at every second or millisecond, but what is my, like you mentioned, a deterministic type of network.
Exactly.
Helps to maintain coordination and control. So having the determinism in an Ethernet, which you remember, Marta, when Ethernet came out, the biggest problem was it wasn't deterministic. You had these issues, but the technology bringing it out and having real-time clock scenarios and having really good, like a PTP type of protocol within Ethernet for precision timing. It's possible and as close to deterministic as you can get in an Ethernet environment. So, yeah, well, I mean, yeah, I think real time is in the hand of the beholder. What does real time mean?
Yeah, that's almost a whole different conversation about the real-time network. So we've being German and being, I suppose, somewhat related, you know, to the German technologies, we've gone with Profinet as the Profinet RT as the IO. We had used Interbus on some of the earlier PLCs. That was a really good technology, but it was just exclusive to Phoenix Contact. So we've gone with the more open technology now, gone with Profinet. So that's the other thing. We try and go with open technologies, OPC UA, Profinet, so on. And yeah, these real-time networks are, it's almost a whole different conversation. But on the device itself, I mean, by real-time, I generally mean deterministic. So you want something to execute every, whatever it is, 100 milliseconds with a very small jitter or very small difference between those 100 millisecond cycles. And that's important for some applications. I know PID controllers sometimes really rely on a fixed time slice to do the integral and derivative calculations, say. So it's quite important to have that deterministic time slicing. But like you say, there's a lot of applications or parts of applications that don't need that determinism. And I suppose traditionally you'd run the deterministic stuff on the PLC and just have that CPU dedicated to that scan cycle, if you like, the OB1, and you'd run your non-real-time stuff just on a different processor or a different device even. Whereas what we're doing is running running a lot of things on the same device, real-time and non-real-time. And the challenge is to not interfere. The non-real-time parts don't interfere with the real-time part. That if you have a 100 millisecond time slice, everything else gets interrupted at that 100 millisecond time boundary, and you execute your real-time application. So that's what we use this preempt RT patch in the Linux kernel for doing this. But yeah, when we say we're pushing the bound, or some users sort of push the boundaries, I mean, we all do it. It is, even though everything's very flexible on this platform, we allow users to do an awful lot. You can log in to the Linux operating system. You can install whatever you like on Linux, if you want. Obviously within the capabilities of the device. But that openness, what's the saying about keeping an open mind? It's good to keep an open mind, but if it's too open, your brain will fall out. So I guess it's sort of similar here. This is a very open system, but that also brings a lot of responsibilities. You can quite easily install stuff on here that will break it, that will affect the real-time part. So you could write a real-time function block in C++, and you can bring in a library that has a sleep instruction in it. So now suddenly your real-time thread is sleeping for 5 seconds, and they wonder why they're not getting the deterministic time cycle anymore. Well, because you brought in a C++ library that's got to sleep for 5 seconds. So your real-time, yeah. So it does give users a lot of flexibility, but there's also a lot of responsibility in there as well. So yeah, it's quite a challenge sometimes, but I suppose that's what people like me are here for. That's what the PLCnext community is there for. If people want to sort of learn about this or are having these sorts of challenges, they can talk to us and yeah, get some help. What's going wrong, So
one of the things that Phil and I find challenge, not so much find challenges, but especially in our markets, I'm sure it's consistent in your area, but the manufacturers living with legacy hardware right through its life cycle to new technology. How do they bring PLCnext? Where does it fit in that space? How do you see it? What have people been doing with it? Are they using it to replace legacy stuff? Are they using it to add more functionality to the floor? How are you seeing it being adopted?
Yeah, that's tricky to answer. So many different applications, I suppose. Yeah, I mean, we don't really have I suppose when you say what some people might want to do is have a pathway from their old system. So even from an old ILC or Phoenix Contact PLC to this sort of technology, that can be tricky because it's so different. Like this new platform is so different. There are things like these open standards. What was the one that sort of aimed to have all PLCs programmed using the same software? What was that one called? There was some initiative a while back, Open PLC or something.
Yeah.
Where I guess the idea was, you just have one IDE, you write your code in that IDE, and you'd be able to send it to any PLC. Like that was the dream, I think. But that never really worked, did it? Because, Siemens have their own specific instruction set. Every manufacturer has their own specific instruction set that just adds their own sort of richness to that platform, and one single programming environment or language was never going to be able to cover all of that. So I suppose that's the challenge we have. So in the past, you have your old ladder logic or function block diagram or whatever. In theory, you should be able to just port that straight to PLCnext Engineer. And there are tools where you can export it as XML and try and import it again, but there's always going to be instructions or a function block you were using or something that just doesn't quite fit. So yeah, it's my experience, it's just been really tough for people to try and, I suppose, migrate an existing application to this sort of platform. So generally we find it's people who are really, I suppose, redesigning their system and saying, okay, this was the old way to do it. Let's think about, and a lot of people have to do that anyway with things like all these security directives and so on. They have to rethink the way they implemented their automation system. So I guess as their old automation system comes to its end of life, redesign it and think about this sort of thing. So it's more sort of fresh applications, really.
Yeah, people are using, I think, codices as well, looking for that type of environment, right? So where they can bring in kind of a open PLC into that environment where they don't have to then rethink everything over again
Right.
as well.
Yeah, and I mean, traditionally, we would have seen Codesys as a competitor because, yeah, that's an idea, isn't it? I mean, it has its runtime, but Codesys doesn't do hardware, do they? They just do the runtime, and they do the programming environment. So we would have, I suppose, traditionally seen that as a competitor to PLCnext Engineer because they do their programming, we do our programming, and you can't really move between the two. But people were saying, like, again, that's one of the first questions, can I run Codesys on this thing? And the answer was no. But now the answer is yes. There's an app in the PLCnext Store. Well, it's a bit of an unusual app, yeah, but you can install Codesys. And in fact, next week in Nuremberg, I'm going to be demonstrating this. You can run Codesys on that device behind Ed there. And in fact, you could not use PLCnext Engineer at all. You could just use Codesys and run the Codesys runtime on there. It integrates in with the Axial Line IO that's built in and so on. We're working on EtherCAT. Sorry, not EtherCAT. Ethernet IP, ProfiNet. Yeah, was it EtherCAT? Anyway, I won't commit to that. But yeah, any of the networks that you're familiar with on Codesys, we're trying to integrate those. So really, it becomes a hardware device that's running Codesys. So we're trying to make it more open and more flexible. But yeah.
No, I think it's definitely a driver, right, in the right direction when we're talking about these open architectures, right? Supporting OPC UA, supporting MQTT is going to be the way forward, where companies can start building their network infrastructure in that sort of open way. So they're not, tied to a particular protocol on the plant floor. They can, I guess, have that choice, not just in their coding environment, not just the language, but the protocols they're using, the HMI functionality. If they want to build out a quick screen, they want to have, on device or on machine type HMI capability. The PLCnext does that straight out the box. So, they can develop really quick applications, start building out their infrastructure really in a very kind of true and tested way, which is pretty cool.
Yeah, and I might just mention, like, just what Ed said there about the types of applications, I suppose, that are being implemented. Just one that I was just chatting to the marketing people here about a few weeks ago is just the range of applications that this applies to, I suppose. And I just thought a really good example of that was, well, Phoenix Contacts is really into this all-electric society. So this is where, and I was actually listening to a podcast from an Australian guy talking to Josh Zepps, I think, on his podcast about it. He had a similar concept that everything is going to be, well, electrified. And I suppose everything is electric already, but things like, there won't be, you won't have gas heating anymore in your house, like here in Europe, gas heating or whatever is quite popular. Everything will just be electric. Your cars will be electric, your stove will be electric, your heating will be electric, everything will be electric. And this is sort of something that Phoenix Contact is really involved in, is sort of promoting, working towards this all electric society. And the examples that they give where, this PLCnext technology has been used in everything from the wind turbines. So some of our biggest customers use our controllers in these wind turbines up in the nacelles, is that what they're called, to control the rotors, and in solar plants, controlling these, the energy management in the solar plants, feeding all that back into sort of electrical substations. So we're just launching an energy controller for substations, the electricity distribution, all the way through to like electric car charging stations. So we have this Charks controller for car charging stations, and they're installed like in car parks and everything. And yeah, just all of this, all the way from the energy generation, energy distribution, and then the energy consumption, even in the factory here. out the back of where I am now, where we actually manufacture all these things. They use PLCnext technology to control, to monitor the energy usage in the plant, and to figure out where they can save energy there. So even just the manufacturing industry out here can also use that. So I just thought it was really interesting to see how PLCnext technology was used all the way in this all electric society, from the energy generation, distribution, transmission, all the way to the sort of end usage. It's quite interesting. It's be interesting to see how it goes in the future.
That move into that space requires a consistent, I suppose, shape and model of how the data moves from one location to another, and having, I suppose, common infrastructure, what PLCnext can deliver, especially with that IT/OT and running those other applications that are specific for the problem you're trying to solve. Like we talked about at the beginning, which one do you use? Well, use the one that solves the problem and the one that most people are familiar with. And having that flexibility just means you can probably be quite, I suppose, scalable as a hardware platform, but solve different software solutions, which is an interesting mix, isn't it? I mean, it's not like in the days you had to buy different models of things, but now it's a common platform, and you have software to help you solve the problem, which I've seen us going towards in a much faster way, allowing the skill of the person to maximize the benefit of that hardware. Oh, that's great.
That's right. Yeah.
And I guess, being, I guess, a modular platform as well, like there's a few bits to the modularity, I guess, of PLCnext. You have those like really cool smart IO, extension points. I don't know if you've seen it, but it's a really small footprint, type thing. All the way to, you've got machine learning extensions, you've got AI on board as well in those sort of machine learning. I guess maybe you can talk to a little bit about the modularity and how you see, I guess, PLCnext reflecting that as an ecosystem.
Yeah. Well, like you say, there's the hardware modularity. So there's the CPU, there's the let's say the directly connected IO modules, like you can see behind Ed there. There's the network devices, the Profinet bus couplers and remote IO. And the hardware modularity, I suppose you can get extension modules on the PCI bus on the left side of this device there behind Ed. So like you say, there's machine learning devices. There's actually safety controller you can plug onto the side of that. You can put additional Ethernet ports on. And just what Ed mentioned before about the P2P communications, colleagues in the US, I think at the moment, are developing a P2P module for the left side. So you get this hardware modularity because there's a PCI bus on here. You can, we even have a PCI bus development kit. If people wanted to develop their own PCI hardware or PCI-based hardware, they can do that with a development kit. But then there's the software modularity as well. Like with Linux, there's all sorts of open source packages that could be installed on the device, obviously limited by the capabilities of the device. But that's what the PLCnext Store is sort of for as well, that people can put these modular components into the PLCnext Store. Other people can see what's available already. They don't have to redevelop it themselves, but then they can use that as the basis for their own development. So one of the very first sort of apps in the store was this thing called the PLCnext Base Library, and that was done by a department in Phoenix Contact. And they just did a whole lot of function blocks that they thought would be pretty useful that weren't included in the firmware already. And they've now been building that, maintaining it, and almost every application we see come in, they use the PLCnext Base Library or some function block out of that to build up their own. So they haven't had to do that themselves. They can just build on what somebody else has done. And that's what I really like about the PLCnext Store is, some of the things you see in there, it opens your mind, and you can sort of see the possibilities of what you might be able to use these for. So I think that the modular software part is important as well.
There's such great value when you see a community get behind a technology and start building, not just within outside of Phoenix, but I've experienced, and probably Phil has experienced, where there's been people in the business who've built solutions for those technology, and they freely give it out or allow us to use it. It just makes it extensible and just gives that extra value in this community apart from Phoenix, obviously. Other people building things, which is just makes it even
Yeah.
even more value.
I mean, I will mention it's not the PLCnext Store is not a charity shop. It-
No.
it's up no, but if somebody wanted to, it's important to mention that if somebody has developed something that they think is very useful and that they're proud of, and they think is well maintained and good quality, and they want to share that, they don't have to be charitable. Well, they can if they want. You can put it in the store for free. You can put a demo in the store for free, but there is a licensing model in there as well. So you can, if you want to become an app developer, you can put it into the store and you can charge a price for that. So you could actually make a business, however big or small, out of developing apps. In our app store, for example, I don't know if other vendors have similar ones. But yeah, I mean, there's some people have got really good apps in there and they charge money for it, and that's great. People use it. It's the way it should be, So yeah, I mean, if people have a good idea for an app, for a function or whatever, and they have it working themselves, they can register to become a developer in the PLCnext Store. They can, there's a whole help system to show them how they can package their app. They can put it up on the store. They can commercialize it, and it's open to everybody to become an app developer as well. And I'll say as well, just when we're talking about modularity, we're moving to and maybe it's a point that we talk about the future. We're also working with partners, with PLCnext Technology partners, external companies who traditionally you might say, well, are either competitors or have complementary products, companies like Festo and Yaskawa. And they are not using our hardware. They have their own hardware. So, Festo are into motion control. They're known for pneumatics and so on, but they broadly, involved in motion control. Yaskawa do drives. A lot of people ask us, do you have drive capability? Well, no, Phoenix Contact doesn't, but our partner Yaskawa does. And what they've done is they've taken the core part of PLCnext technology that runs on our own PLCnext control devices, and we've partnered with them. We've shared that core kernel sort of software with them, that platform software, and they've now adapted that for their own hardware. So they run what we call PLCnext Core on their own hardware. And so they can use all those components that we've already done, the OPC array server, the data logger, the web server, the web-based management, all of these things, and they can build their own unique components into that, whether it's for motion control or drive control or whatever. And so they're now finding that modularity. They now have a ready-made automation platform that they can just build on their own unique components into. And I think that's the way the future is looking, this sort of collaboration, so that everybody's not reinventing the same thing over and over. We just all collaborate, well, as far as possible. It's a nice dream, but we collaborate. We all contribute to try and create the best platform possible, So that's the future.
No, that's great. That collaboration is probably testament in the sense that we're all looking to improve not just our solutions, but also how do we help manufacturing? How do we help them get better? And along the journey. We're getting towards the end of our podcast here today, Martin, but something we always ask all our guests, because obviously you're a student of learning, you've gone from chemical engineering and worked through the processes and where you are today, being quite involved with the PLCnext as a technology specialist, and I suppose you're continually learning. So we're very keen to know what's the next thing you're actually learning, or what are you exploring in this space?
Oh, that's a good question. Well, I suppose my day-to-day work, it's related to what I just mentioned, was this collaboration. I suppose day-to-day I do technical support for our own PLCnext control devices, but more and more I'm interested in supporting these external partners, these collaborators. So a lot of what I'm going to be doing in the future is I suppose learning more about this sort of deeper down sort of these core sort of platform, the automation platform, and helping our collaborators to work with that. So that's from a personal point of view. More broadly, what you guys mentioned, this AI, is really interesting to me. I'm not quite sure how it's going to relate to automation, because I mean, you wouldn't want an autonomous sort of AI running your plant, well, would you? I don't think so. I mean, we're a long, long way from that. I mean, it might be able to write, give you a recipe for banana bread or something, but I don't know if it would run your pharmaceutical plant. But there are ways that AI, I think, can be used. I think, Phil, you mentioned, just generating code. So it's already quite good at generating C++ or Python or Java or whatever. I was amazed when I just had to write something in Python recently, and just Visual Studio just went and like it almost understood. I just wrote a few comments, and based on the comments, it kind of knew what I wanted to do. I was amazed, and I thought this could work in automation as well. I mean, you just say, I need a PID loop to control this. Here's some characteristics of the process, or when this happens, I want that to happen, and it could write. I mean, it should be able to write structured text, ladder logic, maybe. I don't know. So I'd be interested in exploring a bit more of that, about how AI can help, developers, automation code developers, to be more efficient. Obviously, at the moment, it's a helper. It's not going to replace us, I don't think. But I think it really has some good potential. I mean, just from a communications point of view, we're already using AI. I don't know if you've seen, like, Phoenix Contact do a lot of videos, like you said, Phil, some old videos that I did, but our marketing people do a lot of videos, and they used to have to record them in German and in English. And now, in the last year or so, I've seen they just record them just straight to camera in German. Just that's it. And that's their German version. And AI is amazing. It then just dubs it over in English, makes their mouth move in English, which is really weird. And it's amazing. So it's just instantly created this English version of the video. And we're looking at that for knowledge, just for knowledge, sharing knowledge as well. So in the past, I would record a video, we'd have to write the script, and we'd have to do all the coding, and we'd record the screen and all that. But, maybe you could just tell AI, look, make a video about how to write an app for the PLCnext Store, and, it might just be able to create a video for you.
Talking as Martin Boers.
Well, we actually spoke about that. We said, do we use a person that people know already, and we thought, no, I don't think that would be allowed, for data protection reasons or whatever. Because, so we're talking about, maybe you create a new persona, a new fictitious avatar who is now the voice of training for Phoenix Contact. I don't know. We're looking into all this. So, I think just this application across the whole range of automation, this AI, I think, is interesting. What about you guys? What do you see the next big thing as?
Well, I'm definitely learning AI is kind of the rabbit hole that I've jumped down.
Yeah.
And I don't see myself getting out anytime soon. And from an application point of view, I see it as an accelerator. It's the collaboration portion with alongside AI that allows us to, talk naturally to the computer, and it kind of understand more and more of that context window to be able to write the code in more efficient ways. It's not always obviously going to get it 100% until we get it to like 99%. And then there are more and more iterations of models coming out. We've since last 2 years November, we didn't have ChatGPT, and then we did, and then since then it's been like this acceleration of LLMs, and some of them do better at some other tasks. So my what I'm learning is how I can orchestrate AI. How can I use the models that are really good at something and not so good at the others, so I can use like them as puppets basically, to be able to get the outcomes that we need. So that's what I'm focusing on. Yeah, it's really interesting. It is really interesting, and it's getting really quick. Ed, what are you learning? What are you?
What I find, you mentioned before, Martin, about the different codes. When you're programming and people understand ladder or structured text and whatever it might be, and because they don't understand the other version, I find that with the LLMs now, the AI, I could put code in and say, what does this telling? What is this doing? And it's quite good in telling me in plain English and for my language what it's actually doing. So I don't need to learn it to a degree. I can get it to help me learn and understand how the applications are being programmed or used. And that's why I think going forward, that ability for the AIs to connect into our control systems, so you can tell people what's going on, what's happening you can ask it a question, in natural English, and it will come back to you and tell you what's happening in the system in a way that, in a way that makes sense. And I think this involvement in it capturing and be able to take that information, translate it take the data and make it information that makes sense to me. Because you know what it's like today. Everyone's trying to make a graph or a visualization that makes sense to somebody, but doesn't make sense to me. So how do I gain that data to information? And I think I see AI being better and knowing who I am and what my role is and how the data makes sense to me in the infographic that it will come up with going forward.
Really interesting. Yeah.
Yeah, real-time insights with personalization layered on top. That's going to be really exciting stuff. Absolutely. Well, look, thank you, Martin, for joining us today on Unplugged and IoT podcast. And we want to say thank you for taking the time and talking about PLCnext Technology and your, history, being I guess, a Australian as well. It's good to have you on an Australian podcast. I don't know about my accent. It's still a bit on the fence around English and Australian, so we'll see how that one go as well. But so to all our listeners, thank you for joining us today, and we want to thank also Phoenix Contact for making this particular podcast possible. And don't forget to subscribe for more conversations with industry mentors like Martin, and people really striving to push industry forward. So thanks, Ed.
Thank you. Yes, Martin. Again, you're showing us about the technology, the openness, for your candidness. Thanks for sharing your story through the journey with us. We learned a lot of this podcast. It's been a great one. Thanks, Phil. And to our listeners, yes, please feel free to reach out to Martin Boers. I'm sure it's available on LinkedIn and all the other platforms. This probably episode won't come out in time for SPS, but I'm sure when you hear this podcast, you just engage. And yeah, it's been a great podcast. Thanks again.
Thanks, guys. It's been a pleasure.